Okay guys, so let us study about current and electricity. So before starting current and electricity, we need to know what is voltage and what is current. Voltage is nothing but a potential difference. And what is the current? In order to accommodate that potential difference, the flow is known as your current. Let us take one example. Suppose we have a bucket filled with water. We have another bucket which also having water. Let us consider bucket A and bucket B. Now, this bucket is having less water. Now, if we connect this both bucket, definitely water will flow from bucket A to bucket B. The reason behind the concentration or level of water in bucket A is higher as compared to B. Similarly, in case of current also or current electricity, when there is a higher concentration of electron tends to move towards the lower concentration. Same like this water level. Now, if we correspond this video, the difference in level of water can be considered as the voltage and the flow of water can be considered as current. Now guys, if you see, as this level is coming up, okay, then the flow also become feeble. Now, till the time the level of both A and B becomes equal, no water will flow. Means, similarly in case of current and voltage and current also, when the level of voltage becomes same, when both terminal is at same potential, there is no flow of current. So, current will always flow when only voltage is there. So, this is about your voltage and current. Okay, now this was about voltage and current. Now we are going to learn about how to take out the potential at two terminals, voltage difference at two terminals. Okay, guys, please be careful because this concept is so useful while solving the problems. Okay, let us consider point A. Now there is some resistance in between, and this is point B. Voltage at this level, suppose we consider it at VA. Now, voltage at this, suppose VB. This is your resistance R. Suppose if someone asks you what is the voltage at VB. Okay. So, definitely, whenever, suppose VA is greater than VB and we want to take out what is potential at VB. Okay, so whenever voltage is higher, as I told previously, voltage always flow from higher potential to lower potential. Here VA is greater than VB. Now suppose current start flowing from here. Now the sum of current will dissipate here through this resistor R. Okay, so according to Ohm's law, V is equal to IR. So if we need to take out VA minus what is potential drop here or power dissipated here is nothing but I into R. Okay, is equal to V. Okay, the potential here and difference in potential here is nothing but here. Similarly, like suppose you are going to any tour. Okay, you are having 100 rupees in your pocket initially. Now, suppose some toll came in. Okay, now if you put like 30 rupees at toll gate and what you will left with? You left with 70 rupees. Similarly, suppose potential here it is a VA. Now this is your 30 rupees. This is the power dissipated. This is the voltage drop here. Okay, and here you left with the difference of initial and what you consumed. What power you consumed. You can write it as power dissipated. So this is how you can take out the terminal voltages. Guys, now we come to know how to take out the potential at two terminals. Now, many of students I found it they face complication to identify whether the connection is in series or in parallel. Okay, while solving any problem, we'll make one point which will let you know whether the connection is in series or in parallel. Suppose I R1, R2 and R3. Okay. Put your pen at one end. Okay. If you find single way, then definitely they are in series. So suppose A and point B. You want to go from A to B. Well, traveling from A to B, single way, and again we will get single way. No double way is there. So definitely R1, R2 and R3 are in series. Okay. Now suppose I'll put one more resistance R4. Okay. Now check. Again going from here we have single way. We are proceeding with single way. Now see at this point we have two ways. Current has two options. Either it can go from this way, either it can go from this way. I1, I2. Now the path is distributed. Okay. Now your pen has two ends. You can go here also, here also. Now we can consider this connection is in parallel. So R2 and R4 are in parallel combination and rest are in series combination. Okay guys, this is how we can take out, we can point out whether they are in series or parallel. Now few concepts which will be very helpful in solving the problems. Guys, current remains same in series and voltage remains same when there is a parallel combination. Suppose here is R1, R2 and R3. Okay, this is VA and VB. Now, what I told, current always same in series. Suppose some current I1 is flowing from here. Okay, that same I1 will be here also, and same I1 will be here also, and same I1 will be here also. But potential, if we talk about the potential at this end and this end will be changed. As I told previously, just the difference across the this both potential across the resistor you can take out. So current always I1, I1, I1 and I1. Now if we talk about the voltage here is VA, then here it will be VB. Okay, and usually if terminal A or VA is at higher potential, then definitely VA is also greater than VB, and here if it is VC, then VB is greater than VC. If here is a VD, then VC is greater than VD. So what we can see here is that there is a drop in potential, but current always same in the series. As I told you earlier also, whenever some resistance comes in, the power dissipates. Okay, and the drop in potential you can just take out from your simple Ohm's law. V is equal to IR. Okay. Now here if you want to take out the value of VB, VB is nothing but VA minus I1 R1. This is simple unitary method guys, just the difference between 2 points and nothing else. I given you the example of toll plaza. You starting with 100 rupees, toll take 30 rupees from you and you end with 70 rupees. Similarly here also, you started with VA, now the voltage you consumed here is nothing but I1 R1 and you left with voltage VB. So VB is equal to difference, okay, whatever you consumed here. Now another concept, voltage always remains same in parallel. Okay. Suppose we have some parallel combination of resistance. R1, R2 and R3. Okay. If suppose some voltage is here, if you check the voltage across these both terminals, they always remain same. But current in parallel combination varies. What is the reason behind? There is one theory is that current always choose a path where it finds the minimum number of resistance, or current always take the paths whatever comes in between. Suppose some I1 current is start flowing from here. Okay. Now current has two options to flow with. Since current is what? Nothing but the flow of electrons. Okay. Now current when there is a any change, when there is any path, current start flowing there. Similarly, water is there. If you put 4 or 5 pipes inside one bucket, okay, and you fill the bucket with water, you can see from, and if you pressurize the bucket, you can see from all the pipes water is coming. Current is nothing but that is just the flow. So when there is a flow of current, current always take all the paths which comes in between, and it always prefer to go with the path with minimum number of resistors. So here you can see if I1 current is flowing, then I1 will go this side and I2 will go this side, or I1 dash will go, coming this side, I2 will go this side. Okay, again I2 will be redistributed in between two arms. This is about voltage and current division. So make the point: current, series, same; voltage, parallel, same; and vice versa. If we opposite that, again same thing will happen. So this is about current in series and parallel, whether when they are same and when they are not same. Acha, from this point we are seeing the distribution of currents taking place. Here we have one concept. That concept comes under Kirchhoff's current law. Okay, what Kirchhoff's stated in this current law: voltage at node always remains zero. Okay, or else you can say in other words, incoming current and outcome summation of incoming and outgoing current always remains same. Let us check with, suppose I1, I2, I3 and I4. So how to put KCL in a better way? Imagine that you are standing at this position, okay, and see who is coming towards you and see who is going away from you. Suppose you are standing here, you can see I1 is coming towards you, even I2 is coming towards you, and even I4 is coming towards you, and I3 is going away from you. Okay, current is at node is always equal to 0, or sum of incoming current is equal to outgoing current. Let us understand with this. Okay, so sum of incoming current means I1, I4 and I2, and sum of outgoing current is nothing but your I3. So I net can be written as sum of incoming current I1 plus I2 plus I4, and is equal to sum of outgoing current. Outgoing current is your I3. Just put negative sign because direction of I3 is away from you. This is nothing but your Kirchhoff's current law, KCL. Okay guys, now Kirchhoff's voltage law. What Kirchhoff's voltage law states: net potential in any closed loop is always equal to 0 or the supplied EMF. Suppose source of EMF E here, plus minus, here R1, here R2. Okay, so according to Kirchhoff's law, E1 must be equal to, because net change in voltage in closed loop is always equal to 0. So E is equal to I, and what I told, current in series always remains same, they both are in series, so I R1 plus I R2. Okay guys, now many of students have complication while putting the sign while solving the question of Kirchhoff's voltage law. They don't know what sign we have to put. So the easier trick of this, whenever there is a drop in potential, put minus sign. Okay, let us check with this example itself. Suppose I1 current is flowing from here. I1 will go till here. Okay, I1. Okay. Now, when the resistance comes, I told earlier also, drop in potential. Drop in potential, we have to put minus sign. So voltage here, suppose it is VA, and suppose voltage here is your VB. So since the resistance R1 is coming in between, there is a drop in potential across the R1 resistor. So VA is greater than VB. Okay, ready for your first minus sign. Suppose potential here is VC. Okay, so such that VB is greater than VC. Okay, ready for your second minus sign. Okay, now we can write the equation E minus I1 R1. Okay, taking I common because current in series always remains same, minus I R2. Next, sum of voltage EMF inside a closed loop always equal to 0. Okay, if you transfer that side, I R1 plus R2. This is nothing but your Kirchhoff's voltage law. So while solving the problem of mesh loop, just see where the potential is dropping. Whenever there is a drop in potential, you are going from higher potential to lower potential, then put minus sign. And when you are coming from lower potential to higher potential, then plus sign. So why this E is in plus? The current will come, and it is here the negative terminal, because current always flow from positive terminal. Again, when it completes circuit, you are jumping from negative to positive. You are going to high potential. That's why this E is in the positive. Okay, guys. So we got how to apply KVL event. Let us solve the problem in application of the concepts. This question is asked in NEET examination once. Okay. 4 ohms, 8 ohms, 2 ohms is the point B and C. Suppose current I1 is given here 1.2 amperes. Okay. Now we need to take out the potential difference between B and C. So how to solve this question? See, I1 current is going from here. So what is the voltage at this end? Okay. So what is V is equal to IR? Simple Ohm's law. So we can put V is equal to IR. So 1.2 into 4. That is nothing but your 4.8. Okay. So the potential across this end is your 4.8. Now I told you voltage in parallel always remains same. So same potential will be within this also. Then here also V is equal to your 4.8. Okay. Now we need to take out the current in this arm. Okay. So that we'll get the net current here at this point B. Okay. So we know V. V is nothing but, because V is equal to IR. V is your 4.8. I value we don't know. Suppose I2. This is current flowing in this arm is I2. Okay. I2, and what is the value of resistance? Nothing but 8. Okay. So we can, by unitary method, we can take out the value of I2. Value of I2 is nothing but 0.6. Okay. Okay. By simple unitary method, it is nothing but 0.6. Okay. So I1 value is nothing but 1.2. I2 value is nothing but 0.6. Acha, applying KCL then current at node is equal to 0 or sum of two currents. So I net will be equal to I1 plus I2, I1 plus I2. So 0.6 plus 1.2, then this is 1.8 ampere. Okay. Now here the current is 1.8 ampere and the resistance is 2. Then again applying the voltage Kirchhoff's Ohm's law, V is equal to IR. Okay. So V is equal to nothing but your 1.8, the value of net current I net, into 2 ohms, which will get 3.6 volts. Okay guys, in this question we have used 2 or 3 concepts. One, KCL, current at node always equal to 0, or sum of all the currents. Okay, and voltage in parallel always remains same while current divides. See, 2 paths, so current is dividing into I1 and I2. Okay, so this is how very easily we can solve the problem. Just first concept, voltage in parallel remains same, we get V2 here. Okay, current is meeting at the end, then I net value we can take out, then simple application of Ohm's law, we can solve this question within 2 or 3 steps. Jumping back on Kirchhoff's law. Okay, if someone asks you what law actually that Kirchhoff's junction law is followed, junction law means Kirchhoff's current law, whether it is in favor of law of conservation of energy or law of conservation of charge. So either one is correct, either both are correct, or both are not correct. Actually both are correct, because Kirchhoff's law follow both law of conservation of energy as well law of conservation of charge. Okay, how come? Suppose any potential is given and charge is flowing to a junction. Okay, net charge sum ups here, and if we make single way, the sum of all charge will be proceeding to that side. Okay, now this is nothing but law of conservation of energy, because all the incoming routes and one outgoing route is the resultant of all the incoming route, and whatever the net charge is flowing, that will remain same. So Kirchhoff follows both law. Proceeding with next question. This question is about series and parallel combination. Okay, so we need to take out the net potential at this point. So let us find out whether it is in series or parallel. Okay, suppose your current enters from this end. If current enters from this end, okay, then current has two options, here also, here also. I1 here, I2 here. Okay, but I2 current is occupying a single path while going to next resistance. There is no diversion of path. Okay, so definitely, as I told you earlier, when there is no extra path, then they are in series. Then 6 ohm and 6 ohm are in series. How to add up in series? Simple algebraic addition. Okay, so R net, R series will be 6 ohm plus 6 ohm. Okay, that is nothing but your 12 ohm. But now we can reduce the figure into parallel combination of 3 ohm and 6 ohm with having one battery source. See, figure is reduced now. Now these both are in parallel. So 1 upon R net is 1 upon R1 plus 1 upon R2. Okay, or we can reduce after solving this, R1 plus R2, denominator R1 R2. Just we simplified this. Okay, so 3 into 6, 18 upon 3 plus 6, 9, 18 by 9, 2 ohm is your resultant. Okay, if you want to take out the potential difference, V is equal to IR. Since E value is not given, so just we'll keep it as E itself, I. Okay, and what is the value of resistance? 2. Okay, so if we put I is equal to 1 ampere, we'll get the 2 as your EMF of this entire circuit. Okay guys, so today we learn about voltage, current, Kirchhoff's voltage law, Kirchhoff's current law, how to take out terminal voltage, and how to solve the problem based on resistance in series or parallel. So let us revise all this concept. So very first concept was voltage and current. So what is voltage? Voltage is nothing, only the difference between two potentials. Okay, and whenever that difference occurs, and if we join the terminals, okay, in order to maintain that difference, current will flow. Same like water. I had given you bucket example in beginning. Just in order to maintain the level of water, as the water is flowing, similarly in current and electricity, current will flow in order to maintain the level of voltage. Okay, and through that current we can take up all our things like putting bulb or putting all things, so that they will get supplied from that current. Okay, now another concept is how to take out the terminal voltage. Terminal voltage is nothing but, I told you the very first example, if you are going through a toll gate, if you are initially having 100, repeating this again and again, if you are having initially 100, you are going to some point B in between toll gate, okay, it has taken 30 rupees from you, then you left with 70 rupees. Okay, similarly, if some resistance comes in path of current, some voltage will be consumed there. Okay, so at another end, when you need to take out the voltage, you just take out the initial voltage and voltage consumed in between. Okay, just subtract that, you'll get the voltage at another terminal. Okay, now how to identify whether their resistance are in series or parallel? If put your pen on one point, if by moving your pen, if you'll get single path, okay, then it is in series. If you are getting multiple path or two path, or you will get diverted ways, then they are in parallel. Okay. Another very useful concept: current in series always remains same. Okay, because there's a singular path. Okay. Voltage in series always changes. Why? Because if the resistance comes in between, voltage drops down. Okay. Now, because this is all about today's class. Hope you understood. Good luck.